This will be for the con exercise, cube roots. So just some divisibility rules before we begin. Okay, a number is divisible by 3 if the sum of its digits is divisible by 3. So let's say you have the number 372, and you want to know if you can divide that evenly by 3. What you do is take the sum of the individual digits. So this is going to be 3 plus 7 plus 2. Okay, and that's 10 plus 2, which is 12. Now, is 12 divisible by 3? Yes, we know that 12 over 3 will divide evenly and just equal 4. So that proves that 372 is divisible by 3. All right, a number is divisible by 4 if its last 2 digits are divisible by 4. So let's say you have a large number like 1,328. And you want to know if that can divide evenly by 4. You just look at the last 2 digits, okay, 28. And if you can divide that by 4, we know 28 over 4 is just 7. Then that proves the entire thing is divisible by 4. Okay, and of course the number is divisible by 5 if it ends in 0 or 5. And a number is divisible by 10 if it ends in a 0. Okay, so here they're asking the cube root of 1,728. And what this means is, what number multiplied 3 times will give us 1,728? Okay, now I know some of you will use the calculator and do trial and error, but the best mathematical way to do it is to write out the factors of 1,728. So let's see, 1728, the last 2 numbers are 28, so I know it's divisible by 4. Okay, 4 into 17 goes 4 times, carry the 1. 4 into 12 goes 3 times. 4 into 8 goes 2 times. All right. And again, we have a 32. I know that's divisible by 4. So let's see. Here's a 4. 4 into 4 is 1. 4 into 32 is 8. So that's going to be 18. Made a little mistake. I meant to say 108. Okay, 4 into 4 is 1. 4 into 3 is 0. And then 4 into 32 is 8. All right, this last 2 digits, 0, 8. This one's also divisible by 4. That is going to be 4 into 10 is 2. Carry the 2. 4 into 28 is 7. All right, you can break these up into primes, but since I have 3 numbers that match, I'm going to leave it like that. All right, because that's going to come in handy later. And for 27, that's the same as 9 times 3. And for 9, that's the same as 3 times 3. All right, so I'm going to circle the 3's here as well. So let's see, rewriting this, I have the cube root. It's not the square root, it's the cube root. And how many 4's? 1, 2, 3. So I'm going to write 3 4's multiplied by each other. And then how many 3's? 1, 2, 3. 3 3's. Okay, you can't break up the 3's. And the reason I stopped at 4 is because I had 3 of them. So now, anything multiplied 3 times can be brought outside of the radical. So 4 times 4 times 4, that's just 4. 3 times 3 times 3, that's just 3. And of course, 4 times 3 is just 12. So if you multiply 12 3 times, you'll get 1728. All right, so just click inside the box and enter 12. All right, here they have the cube root of 729. Let's see, if we do 7 plus 2 plus 9, that's going to be 9 plus 9, or 18. And 18 divided by 3 is 6. So this is divisible by 3. All right, so that's what I'm going to start with. So I'm going to write 729. All right, start with the 3. 3 into 7 goes 2. Carry the 1. 3 into 12 goes 4. And 3 into 9 goes 3 times. All right. And this is also divisible by 3. 2 plus 4 is 6, plus 3 is 9, and I can divide 9 by 3. So let's see, 3 again. 3 into 24 goes 8 times. 3 into 3 goes 1 time. All right, 81 is the same as 9 times 9. And each 9 is going to be 3 times 3. So we have 1, 2, 3, 4, 5, 6 threes. All right, so we have the cube root of 3 multiplied 6 times. 1, 2, 3, 4, 5, 6. All right, so every 3 repeats can be brought outside of the radical, okay, because we're doing cube root. So 1, 2, 3, and bring that one outside. And then 1, 2, 3. Bring that one outside as well. And those are going to be multiplied by each other. 3 times 3 is just 9. So you just enter that in the box. All right, one more. This is not an even number, so that eliminates 2, 4, 6, 8, 10, and so on. Okay, let's see if it's divisible by 3. If we do 1 plus 3 plus 3 plus 1, that gives us 8. Okay, so you cannot divide 8 by 3 and have no remainder. Okay, so 3 doesn't work. 5 doesn't work because it doesn't end in 5. Let me try 7. All right, dividing by 7, I get a remainder, so that one doesn't work either. Let me try 11. Okay, 1331 divided by 11 is 121. So I'm going to start my factoring tree with 11. So 1331, if you divide by 11, you get 121. Okay, and this is not an even number. That eliminates all the even numbers. 1 plus 2 plus 1 is 4, so it's not divisible by 3. Okay, you're going to have to keep going up, and you'll see that 121, again, is divisible by 11. 121 divided by 11 is 11. So that's just 11 times 11 to get 121. And these are the 3 prime numbers. So the third root of 1331 is 11 times 11 times 11. Okay, and 3 repeats, 3 11s, cancel all 3 and bring it outside of the radical. That's it, it's just 11. So just enter that in the box.